Writing equations from graphs of lines. This is something that it's almost more important than being able to graph as far as standardized tests come, because they're not going to make you graph. They're going to give you pictures of graph and ask you which one it is, which set of equations represent it. So I'm going to first start with the blue line, and my blue doesn't match the blue, but we'll say that this blue is the blue. And so what can I read from that graph? Well, I can look at that graph and say, well, I know that y-intercept. What's that y-intercept? -1, 2, 3. So I know that the y-intercept of this line is, I know the line is y equals something x minus 3. Now I just have to figure out what that something is. Well, that something is its slope. So now I just have to go looking for some other point I can read. Well, I can read this point and this point and this point. Oh, look, it goes through all those little intersections. That means my slope is 1, because it's up 1 over 1, up 1 over 1, up 1 over 1. So my slope is 1. So I could write it like that, but that would look silly. I would be laughed at. It's just y equals x minus 3. Double check, my slope was positive. Yes, my slope was positive. That's it. That's how we write the equation to a line. Okay, since I don't want to mess up my pen colors, we'll say that this red one is the purple one. So what's my y-intercept on this line? My y-intercept on this line is 1. So I'm going to start writing my equation. Now I just have to find the slope. Well, the slope is negative. I know that for sure. Now I just have to worry about the counting. So up 1, 2, 3 over 1, because there's my second point. Let's double check it with a couple more points. Up 3 and over 1 puts me there. Go back to the y-intercept, down 3 and over 1, down 3 and over 1. Yep, looks like that's my slope. -3 over 1. Well, again, that looks silly. They're not going to write a line like that. So y equals -3x plus 1. So I'm doing 2 equations on each graph just to save room. If I was asked the solution of that system of equations is 1, -2, but the blue line is y equals x minus 3, and the red line is y equals -3x plus 1. Again, I just graphed 2 lines at once just to save space. I could say the solution of those 2 lines that are graphed is 0, 2, 3, 4, 5, 6, but that's not what I'm really doing here. What I'm doing here is saying, you know, you're often asked to graph lines, but you're just as often asked, if not more often asked, as far as standardized tests go, to write the equation of the line. So we'll write the equation of the blue line first. And as long as you can read the y-intercept, it's pretty darn easy. If you can read the y-intercept, we're going to say, well, I know my y-intercept there is, what did I say, 6? Yep, 6. Now I just have to figure out the slope. So I just have to find some other line. Now, again, there, I can't read that. I'm just looking for intersections. That looks like a good candidate. Okay, that one's not. And that looks like a good candidate. That one looks the best. And that one looks good. So now let's double check and see. If I say, is that a good point? That would be, let me erase this one here that I know wasn't good. Now I'm going to say, looks like it's down 3 over 2. -3, -2. Let's try again. Let's go up because we're kind of in the way there. Up 3, left 2. Looks like my slope is 3/2. Down 3, left 2. 3, 2. So my slope is 3/2. So there's my equation written in slope-intercept form. If I wanted to write it in standard form, I could do the math and get it in standard form. But that's how you write the equation of a line. Find the y-intercept. And if you've been struggling to graph from slope-intercept, maybe try doing this first. Then worry about graphing. Okay, so my purple line we still have 6 as our y-intercept. Now this one we know has a negative slope. Being able to read those slopes is important. And let's see, looks like there's a point. There's a point. Okay, that's good enough. So it looks like up 2, left 3, up 2, left 3. Again, if I can find it twice, then I'm confident I found the right, I found points. What I mean by that is I know sometimes it's hard to see where are those intersections, especially if you're depending on what medium you're working on. If you're looking up on a screen, it's really hard to tell, but if you can draw in it, usually you can find it. So again, if I was asked the solution of the system, it's 0, 6. But if I'm just asked to write the equations of the lines, those are the equations of the lines. What do you notice about my lines? They're perpendicular. So my slopes are opposite reciprocals. I just wanted to drive that point home again too. Okay, let's try one more. That blue line looks really familiar. My y-intercept is 0, so it's y equals something x, and then there's nothing at the end. Okay, well, what's my slope? Up 1 over 1, up 1 over 1. Oh, my slope is 1. Again, I could write it like that, but that would look silly. So it's just y equals x. Notice I say this line just about every day. I want you to know this line. Knowing what this line looks like is very important. So let me get rid of these because they bother me. So that line of y equals x, very important. Get to know what it is. So now, as I'm looking at it, I know that any point that's on this line is going to be the same x and y value. When x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. When x is 4, y is 4. So this is 3, 3. Again, that would be my solution to the systems. Now this purple line, so this is 3, 3. I'm going to write that. Well, this is 3, 2. This is 3, 1. What do these all have in common? 3. X is 3. Doesn't matter. We don't know anything else about that line, but x is 3. Remember, vertical lines, undefined. But the big thing is x lines are vertical lines. So if I'm trying to be nice, I give you x and y lines. But some of you, that makes it even harder because you don't know those special cases. This should be the easiest one in the world. You should be able to do it just like this. This one is a y line because it's horizontal. Y equals 4. This one is vertical. It's an x line. X equals -1. Done. Should be just that easy to find the equations of the lines. Again, if I was asked to find the solution, where do they intersect? They intersect at -1, 4.